In this video, we're going to be looking at the graph of the parabola and its inverse in the interval x is bigger than 0. Ne? So in this case, they basically give us the parabola not in full. Ne? So if this is our Cartesian plane, then this is our Cartesian plane. So basically your parabola will just be found on this part here. That is what this guy means. Ne? We're only looking at when x is positive, basically. So rather than having both parts of the parabola, you're going to have this part only. Right? Which means you now have a one-to-one function, basically. If they give it to you in this case, it means your parabola is no longer many to one. It's a one-to-one function because they didn't give you the full domain of the graph. They just gave you a half domain of the graph. Okay, perfect. So since the parabola in this case is a one-to-one function, we know that its inverse is also going to be a one-to-one function, right? As long as it's to one, you know that it's going to be a function. So we know that its inverse is a function as well, and we can represent it as a function notation, which is this guy here, right? Perfect. Now let's say we have f of x equals to 2x squared, where x is bigger than or equals to 0. Okay, perfect. And then now let's check. We are now going to do the inverse. Ne? The inverse of this, you remember you switch. Ne? You switch everything. Where there's x, you put y. Where there's y, you put x. And remember, h of x just means y, right? So I'm going to start switching now. Where there was y, I put x equals to 2y squared. Then this switches as well for y is bigger or equals to 0. Ne? So the inverse will always be positive basically as well. Ne? Here. So now we need to make y the subject of the formula. You are going to firstly divide by 2 both sides. So you have x over 2 equals to y squared. Okay, and then you are going to square root both sides. Square root. Ne? Usually we put plus minus here, but you're not going to because they say y is what? Is bigger than 0. So if y is bigger than 0, it means the outside must be positive, right? And you can show that, okay, since x is inside the root, it has to always be also bigger or equals to 0. Do you see it? X is always bigger or equals to 0 because if you have a negative number inside the square root, you're going to have an issue. But that is an imaginary number or non-real roots. Okay. So this is our equation of the inverse. And therefore, we can write it as h to the power negative 1 equals to of x equals to square root of x over 2. Now we have found the inverse of h. Ne? We have answered number 1. Number 2, they want us to find the point where this graph and that graph intersect. Remember, for point of intersection, you equate the two graphs, right? You make them equal because where they intersect, the two graphs shares a common point. It means the two graphs are equal. So I'm going to say 2x squared equals to square root of x over 2. Then I'm trying to solve for x there. Obviously, I always want to remove the square root by squaring both sides, right? And then here you can see that 2 squared is going to be 4. And then x squared is going to be x to the 4 because x squared times 2 is there. Do you see the exponents multiplies basically? So here it was to the power 1. So it's 2 times 1, which gives you 2 to the power 2, which becomes 4. Here is 2 times 2, which is there. This side, the square root disappears. And then you multiply by 2 both sides so that the 2 cancels there. And then you have 8x to the power 4. You move the x this side equals to 0. Then you take x out as a common factor there. You are left with 8x cubed minus 1 equals to 0. Then from here, we can see that, okay, we can see that using the zero product principle, we can say this guy is equals to 0 or that guy equals to 0, right? Then this guy, this is the first point of intersection. Second one, I'm going to move 1 that side. So we have 8x cubed equals to 1. Then divide by 8 both sides. And then I have x cubed equals to 1 over 8. To remove a cube, I have to cube root both sides. Therefore, x will be half. Right, these are the two x values where they intersect. We need to find the y values. Ne? I can substitute here to get my y values. So let's see, I have h to the power that, and then 0 now. I need to know the y value when x is 0, right? So 0 over 2. The answer is 0. So this point, I'll call it point A. Ne? Therefore, the first point, the x is 0. The y is also 0. Now, that is the first point of intersection. The second one, I'll substitute the half into the inverse, which gives us basically half divided by 2, right? Remember, this is x divided by 2, which is basically going to yield to half when you simplify it. Ne? So which means the second point of intersection is B, which is half and half, right? Now it's easy to draw the graphs because we have these 2 points where they intersect. Ne? Perfect. So the third question wants us to sketch these graphs. Okay, let me make our Cartesian plane to sketch. So we have this, right? And then we have that. Let me do this. Do this. I'll say 1, 2, 3. I'll say 1, 2, 3. And always when you sketch the inverse and its function, you're always going to show the axis of symmetry line. And there's a mark for just showing that this graph are going to be reflected along this line. You always use dotted lines and you show that this is line y equals to x. Never make the mistake of forgetting the axis of symmetry line when you sketch the graph and its inverse. The axis of symmetry line must always be shown. Okay. So for the first graph, I have 0 and 0, which is there, which is the origin. Let's use a different color, is there. And then I have half and half. So half is here, and then another half will be there. Right. Then let's see. I'm going to get another point on the parabola. Ne? At least 3 points should be fine. Let's see what is the y value when x is 1. If I were to substitute 1 there, okay, let's see how much I'm gonna get. Let's say we're looking for h. Remember, I'm substituting there. Ne? H at 1 will be 2, 1 squared, which is 2. So when x is 1, the y value is 2. So I'll call this point C, which is 1 coordinate 2. Okay, point C is 1 coordinate 2. Okay. 1 coordinate 2. Okay. Sharp. So it's going to be there. Then that gives me my parabola basically, which goes this way. Right. Sharp. Now the inverse, 0 and 0 still remains 0 and 0. This guy here still remains the same because it's half and half. When you flip half and half, this will still be half, that will still be half, just like 0. This will be still be 0, that will still be 0. But point C, remember, it's basically, we said 1 and 2. So the new point on the inverse, it will be 2 and 1. So on 2, and then there we on 1, you see? So we can all see that our inverse is going to go this way. Obviously, I haven't done it accurately. But yeah, there is our axis of symmetry line, right? So once you have the points of the parabola, you just flip them around and then they will give you the points of the inverse. Ne? And we can see that because the domain was restricted, we can see that the inverse is now a function because the vertical line cuts it only once. Do you see it? It cuts it only once. So there's no that part here. So the inverse in this case is also a function because it passes the vertical line test. Okay. And then now let's check. They want us to do, they say use the sketch to determine if h and its inverse are increasing or decreasing. Okay. You just check the function. Let's see. To check if a graph is increasing or decreasing, you always look what happens as you move from left to right. Sure. As we move from here, going there, what is happening to this graph? It keeps on going up, you see it. So you are going to say as x increases. So you always check what happens as x increases. Ne? As x increases, h of x goes up. It goes up, which means it is increasing. Ne? So it is also increasing. Hence, that will also increase. Because if a function is increasing, its inverse will also increase. If a function is decreasing, its inverse will also decrease. So in terms of increase and decrease, the function and the inverse are exactly the same. Hence, h negative 1 of x will also increase. Okay, sharp. And then let's check the other question. They say calculate the average gradient between the 2 points of intersections. Okay. Average gradient is just basically, you just use the normal gradient formula. And they need the gradient between A and B, basically. So small m of AB is basically y on A minus y on B, or some people say y2 minus y1, which is the same thing. And then here I'm going to have x on A. If I started with A here, I must start with A and then x on B. And then what is y on A? Y on A is 0 minus y on B, it's half all over. X on A is 0 minus x on B is half. So here my answer will be 1. So my average gradient between the 2 points of intersection is 1, which is true because the 2 points of intersection, this graph passes through them as well, né? This graph. And the gradient of this is 1, you see? So they're taking the average gradient of that line, basically. And that's it about this video, ladies and gents. If you found this helpful, please don't forget to hit the subscription button and to share with family and friends. Aluta continua, more content loading. Tango.